Hi students, these notes are over points, lines, and planes, and these are the basic building blocks of all geometric figures. First we'll learn about these 10 vocabulary terms and then how to name some of these basic building blocks. Let's start with a point. A point represents an exact location in space. It actually has no size at all. We put a dot on our paper to represent a point, but that's just so we can see it. It's actually not visible. You all have plotted points before on coordinate grids, and we always represent them with a dot on our picture, and there's usually a capital letter next to it, which is the name of the point. To name a point, we just use a capital letter. We don't actually put the dot in front of it. We only put the dot when we're actually drawing it. Next, we have a line. A line is an object that extends infinitely or forever in opposite directions, two directions that go away from each other. A line has no length because we can't measure its length because it does go on forever. And it has no width either because it's made up of an infinite number of points that are strung together. And if points don't have a size, a line doesn't have a width. The sketch of a line is just what you think of as a line, but we have arrows at the ends to indicate that it goes on and on forever. Sometimes some of the points, remember it's made up of an infinite number of points, some of the points are labeled. In this case, A, B, and C are 3 of the infinite number of points that are actually labeled. We can also name a line with a lowercase cursive letter that you'll see attached next to the line. To name a line, you just need only two of its labeled points in either order with a line and 2 arrows above it. So the different ways I could name the line in this sketch are line AC, line CA, line BC, line CB, line AB, or line BA. All are appropriate. They all mean the same thing. You can also name a line by the lowercase letter that's next to it. Sometimes there's not, but if there is, you can use that. Usually you'll see that on a coordinate grid. And that lowercase letter also needs to be in cursive. A line segment is just a part of a line, and it has 2 endpoints that define its length. So you can actually measure the length of a line segment. This is a sketch of what a line segment could look like. What must be labeled are the 2 endpoints. In this case, it's X and Z. You may have other points labeled in between the endpoints. To name a segment, you're going to put the 2 endpoints together in either order. So this segment can be called segment XZ or segment ZX. Above it is a line without arrows. That indicates a segment. Notice that's different than a line that has the arrows. A ray is also just a part of a line. It only has 1 endpoint, and then the other side of it goes on infinitely in one direction. We can't measure its length because it does go on forever in one direction. Here's an example of a sketch of a ray. The endpoint is O. Notice the other end isn't an end, it has an arrow that indicates that it keeps going. In order to name it, you will need one other point on the ray besides the endpoint. So we actually have 2 to choose from, R or P. To name a ray, you always start with the endpoint first, in this case O, followed by any other point on the ray. So we could call it ray OR or ray OP. The symbol above it is always a line with an arrow pointing to the right, despite which direction the ray is pointing in the picture. This is how we name it. Opposite rays are 2 rays that extend away from each other in opposite directions, and they share an endpoint. Together, 2 opposite rays look just like a line. When you see the sketch of opposite rays, it does look like a line. This sketch shows a ray that starts at Y and goes towards Z to the right side. It also shows another ray that also starts at y and goes through x and points to the left side. Together, they make opposite rays, or a line. So in this case, our two opposite rays are ray yz and ray yx. Notice that they both start with the endpoint that they share, y. A plane is a flat surface that extends infinitely or forever in all directions. This is more of a concept and harder for us to imagine because there's nothing like this out there that exists. All of the things we think of as planes stop, like the cover of a book has edges that stop, but a true plane keeps going. So this is more of a concept that we have to imagine. We can't actually measure the size of a plane because it does go on forever, so it has an infinite size. Sketching a plane can be tricky. Usually it's sketched with a parallelogram shape, and because it does go on infinitely forever and never, we can't actually draw that. So we do actually confine it to having edges. This particular plane contains points A, B, and C. That capital cursive R is actually another way we can name a plane. There are two ways to name a plane. We can pick 3 letters from 3 points on the plane that do not fall in a line. That's said to be called non-collinear. We'll talk about that in a minute. So we could call this plane ABC, and we can put those letters in any order. Plane CBA, plane BAC, plane CAB, any of those are fine. Or we can name it by the cursive capital letter that's usually in one of the corners of its sketch. So in this case, we would call it plane R. So postulates, these are just statements that are assumed to be true. It's kind of like rules or laws that we follow. Don't get too caught up in that. But there are 5 postulates that are really important to know about points, lines, and planes. The first one is that through any 2 points, there is exactly one line. We can always draw one line through any 2 points. So if I have a point and another point, I can always draw a line through them. And this is how you plotted lines in junior high or in Algebra 1. The next is through any 3 non-collinear points. I just realized that I forgot to do some more definitions with you. So hold on, we'll come back to this for a second. So we'll go back to what I was just talking about in just a minute. We have a couple more definitions to define. Collinear, this describes points that are on the same line. The sketch of collinear points may just be some points that are on a line, kind of like this one. A, B, and C are collinear. A way to remember that is linear means line, co means with, so they are with or together on the same line. Non-collinear, non means not, so these are points that are not on the same line. Here's a sketch of 3 non-collinear points. There's not one line that I can draw through all 3 of these points. Now I could say A and B are collinear because I can always draw a line through 2 points, or B and C are collinear, or A and C are collinear, but A, B, and C together are non-collinear. If we were to connect 3 points like A, B, and C and it would look like a triangle, that means they're non-collinear. That's another way you can tell. Coplanar describes points that are on the same plane. Planar means plane, co means with or together, so these points are together on the same plane. A sketch might include a plane with 3 points on it. So we say X, Y, and Z are coplanar. Non-coplanar is the opposite. Non means not. So non-coplanar describes points that are not on the same plane. Some of the points might be on the same plane, but altogether they cannot be contained in one single plane. So in this sketch, while we can see that X, Y, and Z are all on the same plane, X, Y, Z, and P are not all in the same plane. So we would say that X, Y, Z, and P are non-coplanar. So now we're ready to go back and talk about the postulates. So just to review, the first postulate says through any 2 points there is exactly one line. The next postulate, through any 3 non-collinear points, those are points that are not on the same line, there is exactly one plane. So remember, non-collinear points would look like points that if I connected them would make a triangle. So there is a plane that these 3 points are all contained within. The next postulate states that if 2 points are in a plane, then the line that contains the points is also in the plane. So if I have a plane and there are 2 points in them, then the line that I can make by connecting those 2 points also lies within that plane. This next one you might remember from Algebra 1. If 2 lines intersect, then they intersect at exactly 1 point. So whenever you were solving systems of equations, you were finding the location of that point. So there's a line, there's a line. Yes, they intersect right there at that 1 point in the middle. And then the last one is a little bit harder concept to understand. If 2 planes intersect, then they intersect at exactly 1 line. So I'll draw you a picture of what this might look like. So if I have this plane and I have another plane that's intersecting it, it's not the best picture, but they're going to intersect right here at this line. They're going to cross. It's a little bit harder to understand. Imagine like the spine of a book. All the pages intersect at that spine. That spine could be considered kind of like a line. So we're going to do a couple examples before you go out and try some of these on your own. So we've got a picture to the right. This is a better picture than I was trying to draw of 2 intersecting planes. You can see that they intersect at that line UV or line UW or line VW, whatever you want to call it. Example 1 says, name 3 points that determine plane J. I do want to say that normally that J and the K should be in cursive, but something happened with the format when I put it in here. But name 3 points that determine plane J. So all we have to do is look at plane J and pick 3 points off of it. All I can see are the V, the W, and the Z, these 3 points right here. So those are 3 points. V, W, and J. I mean Z, excuse me, Z. What am I saying? Thank you. All right, number 2, name the intersection of planes J and K. So this was that last postulate I was talking about. So the intersection is going to be this line right here. So remember, to name a line, you just need to pick any 2 points from the line, just 2, put them in any order you want, and then put a line with 2 arrows above it. So one way we might name this line is line UV. Or we might say line VW. There are probably about 6 different ways we could name this line. This is just 2 of them. Number 3, name a set of collinear points and a set of non-collinear points. Collinear points form a line. Whether you see the line or not, if you can draw a straight line, then they're collinear. We happen to have 3 points that are on the line that's shown, so we could use those 3 points, U, V, and W. Non-collinear points are 3 points that any points that if you connect them, they will not form a line. So if I pick 3 or more points such as U, Y, and V. U, Y, and V, those don't make a line. Or V, Y, and Z, those don't make a line. So if you connect 3 points and it makes like a triangle, then those are non-collinear. So there's several options you could put there. U, V, and Y would be one. Or if I was to take those 3 collinear points, U, V, V, U, W, those are collinear, but if I add a 4th point that's not on that line, now the 4 of them are considered non-collinear. So let's say I add point Z to that. So those 4 points would be non-collinear. So those are just a few examples. And then number 4, name a set of points other than those in example 1 that are coplanar. So remember, if any 3 non-collinear points are always going to be in a plane, that was one of your postulates. So any 3 points that you would connect that would look like a triangle would be considered coplanar. So maybe U, V, and Z. That's an example of 3 non-collinear points, or a set of points. So go ahead, if there were any questions you had, make sure that you write those down and bring them to class, and we will answer those before you try the practice on your own.